Okay, this is dimensional analysis part 2, where we do some we call multi-step conversions and a little more interesting conversion factor or dimensional analysis problems. So our first problem, we have how many milligrams in 658 micrograms. Our starting point is going to be 658 micrograms, and our ending point, or the units we are trying to get to, is going to be in milligrams. So we place that on the far right. Far left starting point, far right ending point. From here we want to look back into our notes and available materials and come up with some conversions that allow us to do this. And when we do this, we notice in our notes and tables that there is no direct conversion from micrograms into milligrams. But we do have conversions, and this is what this is all about, is digging up and finding these conversions. And they will always be available to you, or you can just ask an instructor, hey, what's this conversion? I need it. So we're going to convert, in this case, we're first going to go from micrograms into grams. And then once we are at grams, we're going to go ahead and convert into milligrams. And the conversion factors that we're going to use to do that are as follows. There are 10 to the 6th micrograms in 1 gram, and there are 1,000 milligrams in 1 gram. And we recall that we always use, or every conversion factor that we build is built from an equal sign. So our first step, going from micrograms into grams, we have 658 micrograms. Put the placeholder 1 right there. We're going to use our first equality right here to go into grams. We want to cancel micrograms, so that means micrograms go on the bottom and grams go on the top. And then we can put on our numbers. There are 10 to the 6th, or equivalently 1 times 10 to the 6th micrograms in 1 gram. Our units of micrograms cancel out, and we're halfway through the problem because the unit we have now is grams. At this point, we're going to convert grams into milligrams. So we drop another conversion bar in. We have grams, and we're trying to obtain units of milligrams. So we're going to cancel grams by putting grams on the bottom and milligrams on the top. Again, we're using the second equality here, and now we can plug in our numbers. There are 1 gram in 1,000 milligrams. Grams are going to cancel out. The only unit remaining in our problem is milligrams, so we know we are in good shape. We're now ready for our calculator. Recall the rules of how to use your calculator when doing these dimensional analysis problems. I'm going to go 658. The 10 to the 6 is on the bottom. We ignore all the 1s. I'm going to divide by 1 times 10 to the 6th. Close parentheses. I'm going to hit equals after everything I do. So I've just did that. Now I'm going to multiply by 1,000 and hit equals. My final answer is 0.658. Okay? So I have 0.658. My answer is in milligrams. Put a box around it. If I wanted to put that answer into scientific notation, there are 3 significant figures in the original problem. Everything I brought in was definitions, so it doesn't count. So in scientific notation, we have 6.58 times 10 to the negative 1 milligrams. You want to pause this video and write down the problems before I start again. Our next problem says the density of a block of wood was 11.3 grams per centimeter cubed. What is the density in kilograms per milliliter? So a little bit interesting now in the fact that our start point has 2 units. Well, not a big deal. We just take our 11.3 grams, and instead of putting it over 1, we just put it over 1 centimeter cubed. Remember, if there's no number on the bottom, there's an understood 1 there. The units we're trying to get to are in kilograms per milliliter. And so we think of this as a 2-step problem now. On the top part of the problem, I'll just say on top, we want to go from grams into kilograms. And that's going to be workable because, a little exploration, we know there are 1,000 grams in 1 kilogram. On the bottom part of the problem, bottom part meaning down here, centimeters cubed, we want to go from centimeters cubed to milliliters. So it's going to be 2 unrelated steps in our dimensional analysis problem. And from, again, earlier information, we know that with the metric system, 1 centimeter cubed is always equal to 1 ml, or 1 milliliter. So we're going to use these 2 equalities to go from grams per centimeter cubed into kilograms per milliliter. I'm going to do the top of the problem first. Bring in my dimensional analysis bar. I'm going to eliminate grams. Well, grams on the bottom, kilograms on the top. We're now good with the numbers. We know there are 1,000 grams in 1 kilogram. And by doing that, we know we're going to cancel out grams. If we stop the problem right now, we'd have kilograms on top and centimeters cubed on the bottom. We're halfway there. We want to get this centimeters cubed into milliliters. So we're going to bring in one more dimensional analysis problem. Even though we are 1 bar away, we're going to deal with the centimeters cubed in this bar right here. So we want to cancel centimeters cubed. Centimeters cubed is currently on the bottom, so we're going to put it on the top. And we're going to put milliliters on the bottom. The numbers here are interesting in the fact that they're equal. 1 centimeter cubed and 1 milliliter. Centimeters cubed cancel. The only units we have left are kilograms on top, and sometimes I'll circle them, and milliliters on the bottom. And those are the units we are looking for, so we're in good shape. From here we can use our calculator. We're going to go 11.3. We get to ignore all the 1s. The 1,000 is on the bottom, so we can divide. And ultimately we're done. We have 0.0113. If we want to slide that into scientific notation, we would say that that is 1.13 times 10 to the negative 2 kilograms over, or kilograms per milliliter. And we can go ahead and put a box around that. One final multi-step dimensional analysis problem just to look at. We're going to go from 5.7 liters into ounces. Again, we have to have resources available to us to perform these conversions. There is no direct conversion from liters to ounces, but we can go from liters into milliliters, and then from milliliters into ounces. And we're going to do that with the following conversions. We know 1 liter is 1,000 milliliters. And then a quick internet search says that 1 ounce is approximately 29.57 mLs. And again, these are definitions, so they do not affect our significant digits and scientific notation. These are things brought in from the outside. So generally speaking, this has 2 significant figures, so our answer is going to have 2. So here we go. 5.7 liters. Again, a placeholder of 1 on the bottom. And our ending point, or what we are shooting for, is we are looking for some number of ounces. Conversion bar comes in. First thing we're trying to cancel is liters. So liters on the bottom. We're using our top equality, milliliters on the top. 1 liter, 1,000 milliliters. Liters cancel. One more conversion bar. We're looking to go from milliliters into ounces. So milliliters on the bottom, ounces on top, which is going to allow milliliters to cancel. We still need the numbers. There are 29.57 milliliters in 1 ounce. The only unit left in the problem is ounces, so we're now prepared to run it through our calculator. We go 5.7, multiply by 1,000 because 1,000 is on top. It equals after everything I do, equals halfway through the problem. Again, we ignore the ones. 29.57 appears on the bottom, so we're going to divide by 29.57. It equals 192.76. Okay, significant figures get a little bit interesting. Our original problem only has 2. So we take the 1 and we take the 9 and we ask ourselves, does the 2 round the 9? No, it doesn't. So we end up with 190 ounces. If you wanted to drop that into scientific notation, we would say 1.9 times 10 to the second ounces. And we can put boxes around our answers. And that is 3 practice problems, multi-step dimensional analysis. The biggest thing, folks, is the equalities. Look for them on the internet, ask an instructor for them, but they have to be given to you if you're going to be able to complete problems of this nature. You don't have to pull them out of thin air. And that's it.